Right. Okay. Another slow day, mainly because I'm lazy. Right. What have we done today? Not very much in terms of the IT stuff. However, I did look at cookiecutter. So cookiecutter is a Python utility, and it's good for creating consistent project layouts and things like that. And I happen to know, or I recalled, that there were cookiecutter templates for salt formulae. So I thought, right, I'll find one of those. Anyway, it turns out there are quite a few. The one that I've cloned and I'm going to modify is pretty good. It sticks to the recommended best practices on salt. And now, the downside to it at the moment is it's got a load of other crap in there like Vagrant, which of course I don't have. The way theirs works is basically when you run their cookiecutter project, it provides you with a Vagrant file, which when you do a Vagrant up, creates a virtual machine, which then mounts the project into the sync folder, which is fine. I mean, that does the job, but it assumes that you're going to have all the tooling on your host computer for doing the rest of the work, and the Vagrant box is really only there for running the tests. Whereas, in my setup, the Vagrant virtual machine is the whole development environment. So all I really want is the template for the file structure, for the file structure of the formula itself, along with, for example, the infrastructure testing that is recommended. So yes, there's that. Anyway, that's a minor little job. So we're ready to go now. Now, the other thing that came up today, while I was perusing Reddit, somebody raised a question about Git, and it's another one of those. It's a fairly simple problem that requires a little bit of explanation. So the issue at hand was this: they had they'd created a GitHub repository, and they cloned it into two directories, okay, to simulate two users. So they test one, test two. And in test one, they had edited a file, then they had committed that, and they had pushed it to the repository. Then they switched to test two, and they did the same edit, okay, but they gave it a different commit. So they said, okay, this is the test two commit. Then they edited it. They added that change and committed it. Then they did a git pull with a rebase, and they were surprised because what happened was when they did the git pull with rebase, they ended up with a history that only had the test one change in it. And so their question was, where did my test two go? Okay. And the explanation requires a little bit of explaining. That's kind of what explanations do. So here's the simple explanation. Let me just change this. Oh no. It's not worth aggravating. Right. So here's the change. Okay. So the way I explained it was as follows. Okay, first of all, I've actually run through the process. Okay, so if we do, if we just do a straightforward, this is the, let's go back to the test one. No, this microphone's going to be in my. So if we go back to test one, okay, and we do a git log, okay, you can see we've got just the test one change. Okay, so if I now switch back to test two, this is at the end of the process that I've just described. okay, and I do a git log on that, you can say I've also got the T1 change. Okay, this despite the fact that earlier I had done a T2 change in there, and I've done the pull. So what's happened? Well, you can find out what's happened by looking at the ref log. Okay, so if we go back to T1, okay, and we do git ref log. Oops. Not easy typing. Right. Oh, it. Oh, Mark, come on, you're not in fire anymore. Okay, so we do git ref log. Okay, now this is in the test one, so you can see this is very straightforward. Okay, I cloned a repository, and I've done a commit. Okay, which has created this new change. If I now do the same thing in test two, okay, you'll be able to see the pull. Okay, so here you can see what's happened here is I've cloned it. This is the manual T2 change, right? And this is where the pull happened, right? And you can see that what this has done is it's effectively replaced the T2 change with the T1 change. So the question is why? And in order to understand why, you need to look inside this, right? So you've got two different commits. Okay, so on the one hand, you've got this commit, which is the T1 commit that starts 6D. And on this one, you've got the T2 commit, which starts 2.1, right? So they're two different commits, and we can look at the contents of those by doing a cat. We'll do it with a pretty print. And right, so this is the T1 change. Okay, so you can see this is the T1 change. So this is the one that was done and is now sitting both at the head of my T2 repository and in the original T1. Okay, and this is the 2.1 change, which is the commit I did for T2. Okay. Okay, so this is the T2 change. This is the manual commit, right? Now, what you will notice about both of these is because I made the same change in both, you'll notice that they both have the same tree object. Okay, and in actual fact, if we pretty print the tree object, okay, you'll see that what the tree object contains is this single blob, which is the file. And the blob, this blob is unique to that content of the file. Okay. Okay, so you can see line 1 change. And that was the only change I made in adding that space change on the end was the only change I made in both T1 and T2. Because the change was identical, it produced an identical blob. And because when I did the commit, it constructed the tree, which had just that one file in it, that was also identical. So when it came time to resolve it with the rebase basically looked at the two commits, T1 and T2 change, so these two commits, okay, this one, and it said, well, hang on a minute, I've got the same tree in both. So these are effectively producing the same result. Okay, and because I've done a rebase and I've basically pulled in the T1 change into my T2 repository, it said, okay, I'll just give you the T1 change because it produces the result you want. T2 change now is effectively gone in terms of the commit. But remember, what you committed is actually identical. Okay, what you committed is so what you committed was identical in both cases. So the result's the same. Yeah, the only difference is the Actually, you can see the difference here. You can see this timestamp is different because the commits were done at different times, because one is the T2 change and one's the T1 change. As far as Git's concerned, that's a difference. That's a difference without a difference. It produces the same thing. Okay. So that explains the mystery of why he was getting confused in terms of what was being committed. And this also demonstrates the value of understanding what Git is doing. If you understand that Git is a version control system. Yes, technically a distributed version control system. This is true. Okay, but okay, it's true that Git is just a distributed. It just is a distributed. But if you don't think of it that way, if you think of it as an object store, then the mental model you have is actually more accurate to what's going on. Okay, so if you look at the tree of a Git repository, okay, this is the key thing. Okay, all the files and directory structures and all that kind of stuff all get mapped to these objects. Okay, and that's what we've been looking at with all of these cat file commands. All we've been doing basically is outputting the content of these objects. Okay, once you understand that, and you understand that these references are just literally just pointers. Okay, so we can actually look at the content of these refs. Let's have a look at head master, because that's the one we're currently sitting on. So you can see that the head of this is this 6002, which is, if you recall, that T1 commit. Okay, and then you can look at things like the logs, which actually show you the history of the changes you're making to those various pointers, and that's what we looked at when we looked at reflog. Okay. And once you understand these kind of intricacies of the internals of Git, and you understand it in this context, I think Git becomes a lot easier to figure out. Okay, so you begin to understand things like, oh, a detached head is when I have a head that is this file, here. Okay, so you'll notice that normally this is a reference to one of these refs in here, which then points to an object. Okay, when you get up with a detached head, what that means is that this head file is pointing to an object directly. In other words, it's not going through one of these refs, so it's not attached to the normal ref system. So it's a detached head. Okay, so again, yeah, these are the kind of things that people get completely mystified by. But if you understand just a little bit about the internals of what Git's doing, it all starts to make sense. Similarly with remotes and things like that. Okay, once you understand that when it's pulling things from the remote, all it's doing is pulling remote objects, which are unique items. Okay, and it's updating these references to point into here. Okay, and when you're resolving changes, all it's doing is trying to come up with a consistent set of objects, or a consistent set of objects. So it's trying to construct a single root tree. If you've got two things coming down which have got different trees, then it has to kind of consolidate those to find a common tree. When you've got common objects, you just say, oh, there's just common objects. If you've got two objects and one has got a relationship to the other via its parents, okay, which is these pointers, okay, then you know you can do a fast forward. When you can find no such relationship, then you've got to do a merge. Okay, so it gives you both objects, and it says you need to create a new object, which is the combination of those two objects. Then it can put that into the tree for a consistent structure. Anyway, for what it's worth, that's the approach I take when teaching Git in my courses. So if you're interested, head on to saltyvagrant.com and you'll see updates as I do this kind of explanation, except a lot more clearly, hopefully, and take you through step by step what Git's doing when it does basic operations through to the more advanced stuff. Anyway, right, that's it. I forgot to turn on the Twitch stream, so oh, it seems it's been working, so I don't care. Okay, I'm going to stop now.